Hello and welcome to the accessibility tutorial for eyes. Today we're going to show you how to model ease of access to transport infrastructure and what is called zonal accessibility, which is a measure of how accessible one part of the study area is compared to another. So we're going to show you how to insert a change to the transport network into eyes, and also how to couple eyes to the transport model such as the Wellington transport strategy model, which we'll be using to demonstrate the process, the inputs for that, and also the Auckland regional transport model can be used in this process too. Alrighty, so before we put a network layer into eyes, there's a few things we have to do in our GIS application to make sure that the shapefiles are ready to go into eyes. The first one of these is to make sure that our shapefile is in the New Zealand Transverse Mercator projection. As we can see here, that's the case for this shapefile representing the transmission gully. The next thing we have to do is to add a attribute called ACC type, as we see here, and you'll note that the values are set to 4, which we will explain the meaning of in just a moment. Okay, so to add the transport layer into eyes, we go to the accessibility tool. We go to our infrastructure layers, which brings up this window here, and we go to network changes, and we've selected roads networks, and we click on add, and we go and find our shapefile. So transmission gully, and we'd say that we think it will come online in 2021, and then we give it a name like transmission gully, and bam, we now have the transmission gully polyline added into our transport network. One thing to note is that if we click on this one here, this just brings up a table which shows us that the ACC type values have a range of possible values from 0 to 6, and we can see here that number 4 is a major highway. So we've set each of the items in the transmission gully shapefile to 4, as we saw before. So the next thing to demonstrate is the zonal accessibility, which is the coupling of the transport models and eyes. And the first part we will show you how to work is using the outputs from the transport models, being the Wellington Transport Strategy Model and the Auckland Regional Transport Model, and taking the outputs from those and converting them into inputs for eyes. So this process is handled by a special GeoProject file developed by RIX, which reads files called trip distribution and generalized cost files. These are standard outputs from the transport model. So if we load up the file here, we can see the file. And we can see the trip distribution and the cost, generalized cost file specified here. Note that these GeoProject files are basically XML files, so we can actually open them up with a text editor. I prefer Notepad++, and we can see here that the names of these files are written in here, and you will see that those names are specified there. So if we look back here, we can see that the path is also specified for these. And if we look in our folder, we can see if we've got our Wellington application and we go into data, transport loose coupling 2007, we can see that all the files are located here. So basically, it's important to make sure that these file names and paths are specified as per the file name or the path structure in your on your computer. So before we can load these files into eyes, we've got to make a few modifications to them as they're sent to us. So if I load up one here that's just sent to us, and as it has been sent to us by the transport modelers, we can see it looks like this. And if we compare it to the format that we want it to look like, we can see that there's a small difference in that this line at the top here has been added, and there are no zero values along the diagonal. So adding this line along the top here is pretty straightforward. And now with these values along the diagonal, what these mean is, these zeros mean is that the transport model, at least for the case of Wellington, although I believe this is not the case for Auckland, the transport model models the generalized cost for within a transport zone, and you can see here that there's this goes up to 225 zones plus a few extras. The generalized cost to move within a zone is 0. However, for the calculation of the generalized, for our calculations, we do not want a intrazonal transport cost of 0. So therefore, we have created an algorithm which assigns the smallest travel cost to any other zone to the values on the diagonal. And you can see here we have some code that we can copy into Excel. But first, what I will do is I will copy that there, and then if we copy this into Excel, into Visual Basic editor, and run this, we can see now that these values have been applied along the diagonal. And once we copy in this value, for each of the files where applicable, these generalized cost and trip distribution files will be ready to be used in the transport coupling. We are now ready to run the transport coupling. As we noted before, this uses a modified GeoProject file implemented inside of the eyes application. One important thing to note is that in this case the year as displayed here is actually meaningless and has no connection to the calculation of the zonal accessibilities. So once that's noted, the steps that we need to take are to open the Write to Excel dialog box, and we want to record the zonal accessibilities. We want to add writing moments so that the values will actually be written to Excel when this year is elapsed. However, as we noted before, this year does not is not directly inputted into the calculation of the zonal accessibility. So the year could be any number, and the results will always be the same. So then we click Start Writing, and we just hit the Step button. Wait for that to calculate, and presto, that's done. And we go back to Write to Excel, and we click Open Excel Workbook, and we say yes, that's fine. And we bring up this number here. So note that we don't actually need the second column, and what we are interested in is going down to the bottom here and selecting the zonal accessibilities for zones 1 through to 225, that which is the number of zones, transport zones for the Wellington region. We note that the residential and the commercial zonal accessibilities are actually the same values as per the current implementation of the zonal accessibility calculations. And just to prove that, I will put them next to each other just to show you. So you can see here that these numbers are the same. So if I copy that, and we'll go over to a new sheet, and I transpose that, and then bring back up the eyes application, and if we go to the zonal accessibility, we get this window here, and what we can do is copy these numbers into these cells here, and there we go. We've got zonal accessibilities which give an indication of the relative accessibility between each of the transport zones as overlaid onto the land use map in eyes. Alrighty, so the next thing we want to show you is how to couple eyes and the transport models, going from eyes to the transport models. And so the reason for this is that it's desirable to update the zonal accessibilities as network changes and population and employment distributions change, say every 5 or 10 years. Now, since the eyes and the transport model results will tend to differ to some degree, it's desirable to actually use the population and employment distributions that exist in eyes and actually import these into the transport model. So this is what the eyes to the transport model coupling does. Next, we want to tackle coupling eyes to the transport models. Our objective is to create a file that looks something like this, which details population, household, employment, education data for each of the transport zones. So generally speaking, from eyes we can generate population by transport zone and employment by transport zone. Note that eyes won't produce the population directly as per these categories. So the distribution of these is taken from the transport model, and likewise we assume a ratio between the total number of households and the total population, and then apply the same, and then apply the distribution, distribute these out according to the ratios that exist in the transport model. Eyes does, however, produce employment numbers at a very detailed level, so we can produce employment numbers for each of these categories. For education, the numbers as per the transport model are used as eyes, at least for the time being. Does not have a facility to estimate the occurrence or transport activity associated with education. The first thing we want to do is to calculate the population per transport zone. So this is pretty straightforward. We just open up our Excel, right to Excel, and we've got 2021 here, say, and a sheet name for the land use count. So we click start writing, and then we run eyes. And then stop it once it gets to 221. Go back to right to Excel, and we can open Excel workbook. That's fine. And we can see here that we have land use counts for 2021. And if we go to one I've prepared earlier, if we use some Excel formulas to reshape the data to get it ready to copy and paste into the next workbook, which we open up here. This is the number of cells per land use by transport zone, and we copy and paste that into there, and we can multiply, and we can supply some values to give the number of people per land use cell per transport zone. And so if those two, if the land use cell counts are multiplied by the population densities, we get the number of people per transport zone. And if we sum those up, we get the estimated population for 2021. To calculate the employment, we use an algorithm which we've built inside a programming language called R. And so you can see the code here. This code executes a number of steps to perform the calculation. For our purposes, we simply want to modify the inputs to 3 of these steps. These steps load in the land use count, which we've already calculated. Which we can see here. So this goes into step 1, so we can this file here, and we can simply copy and paste that in to this one here. Save him. Close that one. The second one is the step 8, which we want to get the current year gross output for the study area. So if we go into eyes, we can find this in the economics module, and we go to the land use constraints tab, and we take the output corresponding to the allocated allocated land use, and we open up P2S8, and if we copy that in there, you can see there that these numbers are roughly similar, so we copy that over to there and delete that one, save that file, and the final one is the employment numbers from eyes for the study region. So for that we go to the indicators tab, and we want to get the employment. So note there are two types of employment. There's modified employment counts, and there's a census of population and distribution employment count. We want the census of population and distribution count, so we grab these ones. We leave out the household one, and we copy him into step 12. And so if we look here, these numbers should be pretty similar, and they are. And so we copy them over, delete that one, save him, and then it's simply a matter of running our R script, which happened very quickly, as you can see. So the final step is then just to copy the population and employment estimates into the input file that we will send to the transport modelers. So this is pretty straightforward. If we bring up our employment calculations, we just can copy these out, noting that they are ordered 1 through to 5 as such. This is important to note because, as we can see here, for whatever reason, and just in this case at least, the employment is numbered 5, 2, 1, 2, 3, 4. So that would just simply be a matter of copying and pasting these numbers in, and we actually want them to transpose themselves. And we can set the values as such by getting column 1 to equal column 1, column 2 to equal column 2, and so on. For the population, we bring up our population estimates which are here, and we copy and paste them likewise over here, and noting that we want to transpose them as well, and we then say that these numbers here are equal to these ones, and copy this down using the formulas tab. And once this is followed through, you will then have a transport model input file that you can send to the transport modelers, who can then calculate the trip distribution and generalized cost files for you, which you can then use to calculate the zonal accessibilities as we showed you before, and then you can iterate eyes further to say 2031, and then re-go through the process again, go through to 2041, and so on, and you have the eyes model integrated with the transport model.